So hello and welcome in this video on random variables. So today we will discuss uh, this concept of random variables, and primarily we will discuss the fundamental concepts of random variable. So first of all, what do we mean by random variables? Okay, so what do we mean by random variables? So when we are having a random experiment, so there are two types of outcomes. So in uh, a random experiment, okay, in a random experiment we may have either the numerical outcomes. Okay, so we have numerical outcomes, or we may have some statements. Okay, so numerical outcomes means when you are rolling a dice, then we know that the outcomes will be 1, 2, 3, 4, 5 and 6. So these are our numerical outcomes. And in the case of a coin, so when you are tossing a coin, then your outcomes will be non-numericals, means you are having either head or tail. So these are non-numerical outcomes. So random variables is something which assigns numerical values to the non-numerical outcomes, just like in the case of coin. Or sometimes we are just focusing on the outcomes rather than the ways by which we are getting the outcome. Suppose if you are having a game of rolling of two dice. Okay, so we are having a game of rolling of two dice, and let us assume that two players A and B are two players which are playing this game. Okay, and the game is that the player getting the maximum sum will win. Okay, so suppose A get let's say 5 and B get 7. So here if you just look at this, so we are just focusing on the total of the two dices, that A is getting 5 and B is getting 7. So here we are not focusing on that this 5 we can obtain in various ways, like 1 4 4 1 2 3 3 comma 2. Similarly, we get this 7 by getting 1 6 6 1 2 5 5 2 3 4 and 4 3. So there are various ways of getting 5, means 4 ways of getting this 5, and we are having 6 ways of getting 7, but we are not focusing on this, means either we are getting this 5 by getting 1 on the first dice and 4 on the second, and or 4 on the first and 1 on the second. So it is immaterial. The important thing is the player who is getting more maximum number as the sum will win the game. So again, in this scenario we also have the concept of random variables. So now coming back to the definition. Okay, so let us discuss the definition of the random variable. So let S be the sample space, as be the sample space associated with a random experiment. Okay, so S is a sample space associated with a random experiment. Then if we define a function x over S to R. Okay, so we are defining this function x. Okay, so here this S is the sample space. Okay, this S is the sample space. R is the set of real numbers. So any such function can be considered as a random variable. Okay, so this is our random variable. So this function is a random variable. So if suppose if you consider this example, so suppose we are tossing 2 coins. Okay, suppose we are tossing 2 coins, then our sample space will be head head, tail tail, tail head, and head tail. So this is our sample space. Now if you define a function x over S such that this x will gives you the number of heads in each outcome. Okay, so when you are tossing 2 coins and you are defining this x as number of heads in each toss. So like if you consider this as x1, x2, x3 and x4, means you are considering this as x1, this second outcome as x2, similarly x3 and x4. So when you apply this function on x1, so again the definition of x is that it will give you the number of heads. So here you can see that in this x1 we are having the value as 2 because we are having head on both the coins. Now when you apply this x on x2, so the value is 0. Similarly, when you apply this x on x3, so the value will be same as x on x4 as 1, because you can see that here we are having one head in both x3 and x4. So in this way we assign some numerical value to each of the outcome, right? So this is how we have the concept of random variables. Now the next thing is the probability of a random variable. So because the random variables are related to the sample space, which is the collection of all the outcomes of a random experiment, so definitely we have the concept of probability to each of the outcome. So values. So if you have to calculate the probability of that x will be 2, so this is, if you look at the sample space, so we have only one favorable case to this, okay, that is your x1. So one is favorable, only one outcome is favoring this, and we are having total 4 outcomes. So the probability that x will take value 2 is 1 by 4. Similarly, when you have to find the probability of x is equals to, let's say, 1, so again you can see that here we are having two outcomes, x3 and x4, which are favoring this value. So we are having this probability as 2 by 4, so this is 1 by 2. Lastly, we have the probability of x is equals to 0. So again we are having only one outcome, which is x2. So this is favoring this value. So the probability is again 1 by 4. So this is how we can assign probabilities to the different values of a random variable. Now if you have to consider the types of random variable, so we are having mainly two types of random variable. So the first one is discrete, okay. So a discrete random variable, you can define this as a random variable. A random variable is said to be discrete if it takes finite number of values or countably infinite number of values, okay. So what do we mean by a discrete random variable? You can say that a discrete random variable x, a random variable x is said to be discrete if it takes either finite number of values or countably infinite number of values, okay. So as we discussed this example, so here you can see that we are having only 4 outcomes which are finite. We are having 4 outcomes, x1, x2, x3 and x4. So this is an example of the discrete random variable. So as a remark, you can note that a discrete random variable represents the counts, okay, represent the counts, or you can elaborate it more like associated with a real phenomena, okay. So a discrete random variable represent the counts. As you can see that the example which we just discussed, this x is dealing with the number of heads here. So this is a discrete random variable. Now the second type is the continuous random variable. Okay, so the continuous random variable. So you can say that a random variable, a random variable is said to be continuous if it takes uncountably infinite values. Okay, so a continuous random variable has uncountably infinite number of values. Okay, so just mention it. So if you are interested in examples, so this is something you can say that temperature of a city. Okay, if you have a large group of students, then you can consider the height of students. Okay, so this is another example of continuous random variable. Means because when you are measuring height or temperature, so it can take any value. You cannot say that the height of the student will be 5 feet, then we are having only 6 feet. So in between this we are having heights. So similarly, when you are measuring the temperature, so suppose it is 39 one day, so you are not sure that it will be 40 or next, or 41, like this. So we may have the temperature as 39.1 or 39.2, like this. So because temperature may assume any value between 39 and 40, similarly 40 and 41. So this is what we mean by continuous random variable. Okay, so this is how we can define random variables and the types of random variables, and how we can assign probabilities to different values of the random variables. And we have the concept of this probability of a random variable because this is associated with the sample space of a certain experiment. So let us take another example here. Okay, so let consider the example of rolling of two dices. Okay, so when you are rolling two dices, then we know that we have total, in total we may get 36 outcomes. Okay, and you are defining, so our sample space has these 36 outcomes. Now you are defining this random variable x on S as x will give you the sum of the outcomes of two dices. Okay, so this is how we define our x. So x will take the values as 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, so when you are rolling two dices, so you get these many outcomes. Now suppose you want to find out the probability for x is equals to 2. So again, if you just take the favorable outcomes to this number 2, so we have only one outcome, which is 1 comma 1, which is favoring this 2. So we have the probability as 1 over 36. Similarly, when you are looking for the probability of x is equals to 3, so we get this 3 as 1 comma 2 or 2 comma 1. So we are having two outcomes. So this is 2 over 36. So you can say that it is 1 by 18. And similarly, you have probability of x is equals to, let's say, 4. So again, if you just look at this 4, so we have 1 comma 3, 3 comma 1, 2 comma 2. So again we are having three outcomes which are favoring this value of x as 4. So this is 3 over 36, and this will be coming out as 1 by 12. So in this way, if you continue, you will obtain the probabilities of the other values of x, like 5, 6 and so on. So this is a very general, or you can say the generic introduction of our topic random variables. In our next class, we will discuss about the discrete random variable in details, and we will take some problems on the discrete random variable. So that's all for today. Thank you.